And I'm very pleased to be playing host today to exceptional leaders across the industry who are working on integrated SIM. And we'll go through a little bit of what integrated SIM is, what are the advantages of it, what choices we have, what are some of the trends shaping IoT where iSIM has a true differentiating advantage for you. And in case through the event of Hardware Pioneers Max, you have not had enough acronyms thrown at you for your acronym bingo, I will fulfill that card through my slides at least. But hopefully we'll also cover some of the ways in which you can innovate with areas that have been discussed, particularly in this room just a few hours ago, a few minutes ago even, around embedded intelligence, around designing for NB-IoT and low-power WAN networks, trying to make sure how you can design battery-efficient and energy-efficient IoT. Some 40% of you are looking to take your products connected. There are another 20% that are looking at introducing IoT products. So today we have some leaders in the ecosystem that Kigen works with that can support you with this. And I would invite you to make this panel really, really interactive and help us shape the dialogue on how this is really useful to your work as well. So at Kigen, we've been really proud to be sponsors of Hardware Pioneers Max, and we've co-located an invite-only event for the ecosystem that is convening around integrated SIM to take an acceleration for our customers forward. And we'll give you a little glimpse of that too. So here today in the audience, you've got folks who have been attending our invite-only event called iSIM Pioneers, as well as the larger conference. And hopefully you'll get to kind of get a sense of what that event was like at the networking and the drinks that follow afterwards as well. So with that, please allow me to introduce my panel. And please, could you put your hands together to give them a warm welcome? I'm going to ask you to welcome them, and then hopefully they are going to introduce you. But I have Avishai Shraga from Sony Semiconductor Israel, Juan Noguera from Flex, and Henrik Flodel from Alif Semiconductor. So I'll go through a little bit what iSIM is, and then they will take stage, tell you a little bit about themselves and what they are doing around integrated SIM. We've all had a long day, so we're going to sit and present. This is a relaxed panel, so feel free to put your hands up, interrupt, make it interactive, okay? So, integrated SIM. In Kigen's journey around IoT started from when we were part of the ARM company. And around 2018, there had been a strong realization through about 12 years of research work in supporting a wide ecosystem of semiconductor and chipset manufacturers that radically new approaches were required in securing and supporting the size, the cost, and the scaling requirements of IoT. And that's where integrated SIM was born out of. It takes the concept and the very, very well-known standardized model of SIM-based security that's present in mobile phones and takes that to the IoT world to address those very, very specific requirements that IoT throws. So here's the acronym bingo slide. But we started off with the technical benefits of integrated SIM. And what you have is the SIM model. So it's been going through a miniaturization in size ever since sort of over 30 years. And in 2016, we had the introduction of the embedded SIM, along with which there have been advances in reprogrammability and ensuring that there is remote provisioning capabilities present, making it truly that eSIM model. And we take that eSIM model forward to really integrate the radio and the MCU and the SIM security model around the SIM OS, as well as working with a secure enclave into one integrated piece of silicon. And that's where the iSIM comes through, which provides a significant benefit in terms of how compact devices can be. And today at our iSIM Pioneers event, we've seen some examples of how such products have been commercialized into really exciting, really and really unique new business models and use cases that haven't been addressed by cellular IoT before. And so you can achieve products that are 98% smaller than eSIM, providing that compact form factor. But alongside that, you get the temper resistance and standardized model of security such that you can take advantage of globally available connectivity. Whilst it's really easy for us technologists to get very excited about the technical benefits of something that allows you to address the battery constraints, the energy efficiency requirements, one of the things that has been a true realization from working together with these issues with the ecosystem has been about how much benefit it brings in terms of businesses who are making hardware to really ease the logistics around how SIMs are acquired, are provisioned, both in factory as well as in the field. And so today we will explore some of these areas. And as I mentioned at iSIM Pioneers, we've seen some examples which is, iSIM is enabling through these standardized models. So it takes the consolidation of hardware into these security locations that are present on chip, as well as using models that are prevalent in the internet around TLS mechanisms, so that you can actually do chip-to-cloud data exchange for faster service creation. And so integrating the SIM is unlocking very new and unique use cases. I've got a little bit of flavor of the examples that we see in terms of location and trackers for both logistics, so things, mobile assets, as well as light and compact things such as pet trackers. We've also seen many smart city applications, particularly in the realm of micromobility. And all of these first productized use cases of iSIM are really contributing towards the sort of impactful actions, both for security of people, meaningful actions towards sustainability for the planet, and helping address some of the goals such as responsible material use, reduced use of plastic, for example, and reducing the carbon burden on businesses. And we were very proud that today we were supported and we could show the latest available iSIM hardware. So we had a choice of modules now available, choice of chipsets coming to the market, and increasing momentum around standardization that's supporting the growing understanding of where iSIM can really provide an advantage to hardware manufacturers. So with that, I'm going to turn the table over to our panelists. So please welcome Avishai Shraga, who's going to talk us about the security requirements around cellular IoT. Thank you, Avishai.
Hello, everybody, and thanks for coming. So I'm Avishai from Sony Semiconductors Israel. And I'm heading the security technology activities in our company, which made the decision more than 6 years ago to integrate a lot of security into our chipset family, because we realized that as any other compute device, security will be a fundamental requirement in all devices. And when the market will grow, then the attacker communities will also join the game. And we wanted to make sure that our chipsets will be secure, or will enable our customers to provide secure devices. So we are Sony, part of Sony, which is a $80 billion company with multiple activities from movies to PlayStations, and also doing a lot of silicon around sensors and IoTs. Sony acquired our company back in 2016. We were an Israeli company called Altair, focused on IoT for or LPWA IoT. So this is our focus, and our devices and chipset family is optimized for the LPWA IoT use cases, battery powered, very efficient, very small cost effective. And now we are Sony Semiconductors Israel, and our chipset brand for IoT is Altair, the former name of the company. So we do, as I said, a family of chipset for IoT and other technologies, but our IoT, cellular IoT chipset are the benefits that they are enable fast time to market by having all ecosystem partners on board and enabling our customer to focus on their core compatibility and get all the what we call the connectivity and security just out of the box. We help the design. As I said, our chipset are designed for IoT, very optimized to the IoT use cases. We are part of Sony, so we can promise that long-term support on our devices and chipsets. And as I said, the security is one of our core values of our chipsets. So this is just an example of our first generation chipset, which is commercial and selling today in millions numbers. And this chipset and all of the newer chipset in the family include a lot of security integrated into the hardware. Among that two integrated secure element, one is used for the integrated SIM solution, and the other one is used for application layer security, enabling the application layer to secure their value proposition end to end. And you know, we hear a lot during the day, at least in iSIM Pioneers, about chip to cloud security, and I would like to extend it and to say that security needs to be sensor to service and not only chip to cloud. So chip to cloud is essential part in securing the interface, but our security suite on the chipset also enables designers to secure everything from local attacks and from the sensor to the cloud or to the application. Thank you.
Thank you very much. Oh, there we go.
No, I have my own. What is the next one?
Yes, next one.
Okay, thank you, V, for having me here and having on this nice event on hardware and pioneers and iSIM pioneers. My name is Juan Nogueira. I'm working for Flex. Flex is not a known company because we don't sell products, but we do manufacture and design many products out there. Probably some of the products you have at home or you are used to have in your hands has been designed or manufactured by Flex. So if there is something we know about at Flex is to make hardware. Yeah? So we don't do software, but hardware. We are experts on this area. So one of the things we find out, I mean, I'm responsible for in the company for bringing all new technologies related to connectivity into the company and be able to offer this to our customers as a consulting or as a service, you know, to help them to incorporate these new technologies in their products. So we find out that in the IoT business, most of the companies, they have no clue about hardware, you know. So there's a lot of software companies, or the first time they come to a product in the market. So bringing a product in the market to use to offer their services using hardware is a tough work. So designing a new product is a really time-consuming, very expensive, very iterative process, and most of the time customers not sure if it's worth to develop the hardware already from the beginning, or if having something which would help them to test this on the field quickly will be something more appealing, more interesting, more beneficial for them. So that's the reason why we develop a platform which we call the iEnabler, which help our customers to move quickly from a IoT concept to a field test without that much effort. Taking what we have already available and then bring this in a later stage if the concept, the trial and the tests are successful. It's very easy for us to move from this initial phase to industrialization, because what we design, we always design for manufacturing. Yeah? So this platform is called iEnabler. It has a bunch of sensors and connectivity technologies in there. So we use this platform to facilitate the access to hardware to IoT customers, but also a vehicle to introduce new technologies in connectivity to them, so that they can have this hardware and test what is narrowband IoT, what is iSIM, how it works, how is now satellite, whatever new technologies comes into the IoT space. We want to incorporate in this platform and make it available to our customers in an easy way. So that's the main reason. So this is the interior, as we are in hardware event. So this is how the iEnabler looks like. It's all about hardware, and of course there is some software on top of that to facilitate the usage of this hardware. But this is what is inside of the box. It's not a product. It's something we use as a vehicle to help our customers to jump into the IoT space and get familiar with these new technologies. That's all.
Thank you. I think next one.
All right. I'm going to stand up because otherwise I won't see my slides. So my name is Henrik Lodell. I'm marketing director for Alif Semiconductor. And we make devices intelligent, or intelligent devices, depending on kind of how you phrase that. We're a relatively young semiconductor supplier. We got started in 2019, but the team has decades of experience from the large suppliers in the industry: NXP, Microchip, Atmel, Freescale, you name it. Our founders have been running a lot of those companies and made millions, literally tens, hundreds of millions of devices that are being used every day in all kinds of products today. So we have a lot of experience in kind of putting together this kind of technology. What we're focusing on is essentially to create platforms of highly integrated processors that enable a very dense integration for IoT devices. We kind of started out by looking at all the building blocks that people have to get their hands on in order to create an IoT device. And we wanted to create a number of different processor families that can integrate all of the things that you see here on this slide. Have scalability on the processing side, from single to multi-core systems, everything designed on technology platforms and using semiconductor design tricks to enable long battery life, not just for the smallest devices, but across the entire range, so you can have power savings even if you need to run a full-blown Linux stack. Very strong security and everything built in from the ground up, and then a very high level of functional integration, as I mentioned, both in terms of integrating RAM, integrating non-volatile memory, integrating advanced peripherals, integrating wireless connectivity, and with that also making sure that we integrate the SIM piece of the cellular connectivity in a way that makes it take up as little space as possible, so that we can be used in an efficient way in wearables, for instance. And one thing that we are doing, and this is based on feedback from customers that are looking 5 years ahead to see what do I need for my next design. We decided to include accelerators for machine learning models and for kind of AI type use cases in our devices, both the MCUs and also the MPUs and the fusion processors that we do, so that we can very efficiently handle essentially all of the use case classes for machine learning, vibration, voice, as well as vision, in a microcontroller form factor with microcontroller characteristics. If you saw any of the presentations from Edge Impulse today, it's a very good partner of ours. I'm sure that they talked a little bit about the results that we're able to achieve running those type of workloads on our devices. This is a busy slide. I'm not going to cover everything that's on it, but this is kind of a justification, if you will, as to why a company like us needs to exist, why somebody would want to create a chip supplier in the 2020s. There are, at least in our mind, a number of marketing gaps that a company like us can address. And especially this one about discontinuous solutions, I think is really important, because what we mean by that is essentially, if you look at other suppliers, they tend to have a number of different families of products, but they're architected differently across that spectrum. So you write your code over here, and then you want to move to another processor in the lineup. It doesn't really work well. You have to change a bunch of things. You have to port your software. You have to get new drivers. And it's very difficult for you to do that. We don't design our platforms that way. We design a superset platform that we cut that down so that we can have a very sort of standardized way of interfacing with anything that we put in our chips, from the smallest device to the biggest device. And then all these other things that you see on the list here, inefficient wireless connectivity, not the least, fully integrated monolithically. So not as system in packages or other tricks. We have everything on the same piece of silicon in everything that we do. And to kind of show you an overview of kind of how we scale in terms of features and functions in our devices, and this is very coarse, I'm not going to go into the gory details, but single core MCUs, you have everything that you would expect from a microcontroller, with the addition of an accelerator for AI, as well as a camera interface to feed that accelerator images so that you can implement very efficient kind of IoT camera devices, single chip devices essentially. In the dual core version of our devices, there's 2 MCU cores, and we use ARM technology for the user side of our devices. We use the latest version of ARM's IP. It's the Cortex-M55 core. It's the Ethos U55 MPU. And these devices are configured with a high efficiency side and a high performance side, so you can keep one core on all the time to detect environmental differences, and then when something needs to be classified further, wake the high performance side up and let it do that very quickly. When we go to bigger devices, we bring in a lot of high-speed interfaces, graphical processing units, as well as MPU cores, so that you can combine a Linux environment with an RTOS environment on the same chip. And then we go all the way up to quad-core, where we can have 2 MCU cores, 2 MPU cores, everything that you could ask for in a simple package. So we cover a lot of different applications with the same platform, and everything can be supported with wireless connectivity and also positioning integrated. So that's it from me.
Fantastic. Thank you very much. So we come to the Q&A section of our panel, and I think what's really interesting is all 3 companies have very unique ways of approaching how do we look at energy efficient hardware and design solutions and accelerate them. And I think that's really been quite an exciting way to at least show you some ways in which you can use iSIM in your design. So I'm going to kick off the Q&A section with a couple of questions I have, but please, could you think of some of the questions you have and raise your hand, and we'll get a mic over to you so that you can be heard loud and clear here. But for the benefit of everyone here, I wanted to ask you start with a really, really simple question, but who should design with iSIM? Go on.
I mean, at least in my opinion, and I mean, I know that there are some use cases that I might not be aware of, but in 2022, I think if it's something that is enabled with the hardware that you need for the other functions, I can't really see an appealing reason not to design with iSIM, because you have a benefit of reducing your bill of materials, you have a benefit of reducing the overall power consumption. you have a potential at least to lower the cost of the design. And also, we heard some very interesting statistics in the sessions that Kigen was doing in the room over there about the amount of plastic that the external SIMs generate in a year. So.
Yeah, so just to kind of paint some color to the stats, I'll repeat those stats. So about 4 billion SIMs are shipped around the world every year. And in my slide, I showed you the sort of mini form factor of SIMs going to nano SIMs, and reducing that form factor by half means that there are 1,700 tons of carbon just saved by doing that. Plus, a material change within that would save another 1,900 tons of virgin plastic use that is converted into carbon burden for businesses. But this is happening on a regular level. This is sort of from every MNO. This is something that would add up to support the sustainability goals. Fantastic, thank you for that. Any other drivers that you see customers adopting iSIM technology?
I fully agree. I think any customer designing to use cellular connectivity, they should design for iSIM. I mean, for me, there's no point to continue using plastic SIMs in the future. Everything goes in favor of iSIM for everywhere. I mean, not only plastic, power consumption, size, less component in the supply chain. So it's everything. All benefits. I don't know why some customer that needs cellular connectivity may not want to use iSIM, at least in the future, not today or from today even.
Yes, I also want to add that in my mind, in the future, everything will be using iSIM. It's an evolution, not another solution that will live in parallel to other solution. And whoever wants to be, to adopt the technology at those stages and be a leader and have the opportunity to impact how this, we call it form factor, but it's not really only a form factor, it's a new supply chain, it's a new life cycle. And there are a lot of, this new supply chain that iSIM goes through, which is the device supply chain, has a lot of impact on the production, on, of course, the cost, the power. It's the normal things of integration of any other IP, but in the case of iSIM, it impacts the out-of-the-box availability of your device, how complicated it's for your customers to use cellular. So I think that on top of the fact that everybody will use iSIM eventually, and the earlier the better, I think that people that want really to impact on where it goes and to help optimize this supply chain to IoT, then join early. And I think also this opens a great opportunity for IoT that are not using cellular at all to join the cellular ecosystem, because it makes it as simple or even simpler than other connectivity, with all the goodies of cellular, of coverage and reliability and availability, and no need to find an SSID and to connect to it. So the sooner the better.
So we did not script this answer or this question, so I couldn't have asked for a better endorsement of iSIM. So you talked a little bit about new use cases coming into the cellular realm, making sure that cellular IoT was more accessible to them. So can you talk a little bit about some of the verticals you all see in this happening in?
So I think we see all kinds of activities from our ecosystem partners that trying to take use cases that of IoT that are not cellular into the cellular space using iSIM. We know the activity around white goods with cellular to enable a manufacturer to have preventive maintenance and to be able to identify issues with the device, or even shut it down in case of a recall event. And in this example, for instance, clearly Wi-Fi, at least before iSIM, is simpler and maybe still a little bit cheaper. But the question here is who has the interest that the device will be connected to the network? If it's the manufacturer that have the interest, then cellular technology ensures it will be connected. But if if the customer need to connect a device to Wi-Fi without screen and keyboard, good luck with that. Then most likely it will not be connected. In case of healthcare cases where reliability is critical, and of course all kind of new form factors. There is the Sensus Smart Label, which is also part of the Sony group, that has a very thin, flexible device for tracking. And in order to enable this kind of use case, you need a small enough device that allows the flexibility without breaking any component. So integrating and having a very small chipset or very small module even with everything inside enable those use cases, wearable use cases, smart shoes, etc.
I like smart shoes. That I'm waiting for that, uniquely identifiable, so that when you walk into the room room recognizes you whether you're allowed in or not. That might have been useful for some events.
Yeah. No, I think this is a good point, because it's a conversation I had in the last months with many customers. I call it this new entrance of customers in the cellular space. Or I mentioned that as a smartphone in the middle. So to get rid of this smartphone in the middle, which is always there. We have all the smart connected devices, but smart connected devices means Bluetooth to a smartphone to the cloud. Yeah. And what he was mentioning about who has the interest in having the connectivity or the device connected to the cloud, to the network, is the manufacturer. We have been talking to healthcare customers are more open to that, because they see the risk. As you have more and more health devices on your body, that controls your diabetes, and it may have a malfunction. So you are relying on the distance to the smartphone of the customer, the battery of the smartphone of the customer, if the customer has decided to download the app or not. So at the end of the day, you are in this risk, so you cannot really have a direct connection to your device. You have a connection to the smartphone of your customer, And this also prevents you, not only in healthcare, but also in home appliances. You may monitor your vacuum cleaner, and when you detect it's going to break, you can ship a replacement to the customer. So you have really what experience with this customer. So you can improve the custom fidelization. There are a lot of benefits, but of course there is still this. In cost, we are still fighting against a Bluetooth chip, which is can be an $50 price. So, but this is just the time to maybe to start to think in this direction, maybe with high-end devices like in medical. But I think with the time we will come to these situations as well.
More models of that.
Yeah.
I mean, you can kind of think about it, the way that I like to think about it, and the way that I like to talk about it is it's about efficiency on some level, right? We kind of market our devices as edge devices. These are things that can do edge compute very efficiently in terms of processing and very efficiently in terms of power consumption. But if it's an IoT device, at the end of the day, it will still have to communicate. It will still have to be on a network. And cellular is an easy network because you don't have to create any infrastructure for it. You can just deploy the device, and that appeals to a lot of people. But the cellular connections tend to be metered. So if you want to send all your data all the time over cellular, as somebody who sells that device that has to buy the plan for the device, you end up having to pay more unless you can do efficient processing on the device with low power consumption, so that you can afford to do that processing on the edge instead. So it kind of, all the calculations just points the efficiency needle towards using cellular, and then, well, I can use a plastic SIM, or I can use something that is integrated, minimize the footprint, reduce the BOM cost, and all the other good things that we just said. Yeah, what's not to like?
Fantastic. So are there any questions in the room? Yes, please.
Hi, thank you very much for the talk. In my previous company, which did vehicle tracking, we had a SIM card which roamed onto multiple different networks through agreements with the network operators. But then a couple of years down the line, one of their agreements fell through, and therefore we had a load of devices out there where we needed to get the SIMs replaced because there wasn't the coverage there. How would this be mitigated if the SIM was physically on the board?
So there is extensive activity in the GSMA in the past almost 10 years, I think, around embedded SIM and integrated SIM. You may hear about M2M or RSP. And the idea there is exactly what you said, that if the SIM is soldered or integrated, it doesn't really matter. Physically you can replace a soldered SIM, but the cost of it will be probably more than replacing the device. So it's identical in that sense. And this activity is mostly around your ability to change connectivity provider remotely over the air in the case, in the simple case where you just can pay less for connectivity, or that the coverage is better and then you more power efficient with your throughput, or even in the case that you mentioned that your provider runs out of business. So this is addressed by standards exactly because of one of the main issues that you raised.
I think it's the scenario that we all want to get to, where you really can deploy a device where you will never have to send a truck out to replace a SIM card ever again. So, we just have to, as a group, help push those standards forward. And because I know that the operators are kind of, well, I like the lock-in effect of you not being able to switch my SIM, but nobody else likes that.
And I think it goes towards sort of having these continuous solutions, and it is about when you have out-of-the-box connectivity, you really do need to think about how you're going to ensure connectivity across the entire life cycle, and that's part of that remote SIM provisioning standardization. Excellent question. Thank you very much. Anyone else? We have two questions.
So if we consider much wider perspective, like including the cell phone market, who or which market accelerate iSIM? The cell phone first or IoT first? Because every time cell phone accelerate every technology rather than the IoT. But for iSIM, which do you think?
I think that question's for you, B.
Yeah. you are the iSIM guy. You are the SIM guy.
Can I borrow a microphone? So that's an excellent question, and we do believe that there are many ways in which iSIM is becoming a de facto and accepted across the smartphone platform as well. So we will start seeing that very soon, and as you said, smartphones have been a great accelerator for this. Whether it's IoT or smartphones alone, consumer devices, I think it's really important to consider how efficiency plays a part and the robust security. So within the smartphone, we know that a huge amount of that trusted services, a lot of the use cases, digital IDs, the kind of mobile wallets, access and payment technologies, all of these benefit from a very strong authentication, and the root of trust that's provided by iSIM will certainly be a great advantage in unlocking some of the things that we haven't seen thus far. Plus, when we talk about the ecosystem of IoT products that surrounds the smartphone, to actually liberate those and actually build out-of-the-box connectivity into those can bring many more benefits, whether it's healthcare, whether it's smartwatches and tokens, fobs, whatever that looks like. Those product post to children are changing from every 2 years, but I think there is a huge amount of potential that we are to see in terms of iSIMs being accelerated in both.
Yeah, and just a comment. I think if you look at the market, two smartphone manufacturers are covering maybe 90% of the market. So if you convince them to use iSIM, then you have immediately a lot of use cases. But I think it's going to be easier to enter in the IoT space because you have much more variety of manufacturers and customers, so offerings, let's say.
Yeah, I think that in the IoT space, it solves a real challenge for IoT deployments. In the cell phone space, I don't think they have the challenge of space. They are very established. If they have to choose between investing resources in designing integrated hardware versus soldering existing hardware, they don't have the challenge. They may decide to defer these investments. But in the IoT space, it's a real enabler for the numbers, or for the hyper IoT, the numbers that we see in all researchers, because bringing device to market with connectivity that has no human interface is a real blocker, and iSIM address a lot in the direction to solve it.
Fantastic. Thank you very much. We are just out of time, but my panelists will be available around the networking event as well. We look forward to more of your questions. Please reach out to myself or any of our panelists. But before we part, I would like you to please give a very, very warm thank you to all our panelists. Thank you.